Curiosity. Kill the rat. Curiosity. Kill the rat.
Hello, everyone, and welcome back to another episode of Curiosity Killed the Rat. This is part 3 of 3 in our Pint of Science special, for which, once again, we are super grateful to be a part of. My name is Matt. I am not a scientist, but boy, do I sure love learning about scientists. It's what brings me back here every fortnight.
Oh boy, do I love
jeez.
learning.
Oh, what am I, a
Rick,
goddamn
do I love
nerd?
learning.
Well, as you can
Sorry.
hear, I am always joined by my lovely, lovely co-host and today's featured guest, Kate.
Yeah, that's really weird being referred to as both the host and the guest in one fell swoop. I feel like I've got very big boots to fill today because I need to ask myself questions and then also answer them.
I mean, I'm going to be asking you questions
yeah.
as well. It's not that ego-stroking.
I sure
it's
hope
not just a
so.
self-interview.
Damn.
I mean, there's going to be a
this
fair
whole
bit
thing
of that.
planned.
But
This whole 2-character script
what
where
I'm
I was
just
going to
here,
read both
I'm
parts.
just here to intro
Not
you
really.
and bring you out, and then you just monologue for half an hour. Honestly,
Yeah, that's all
I'm
this
down.
is. When Pint of Science was like, Kate, talk on your own podcast about your own research, I was like, oh boy,
Because
could it
obviously,
get any
you know,
better?
we've had you talk on this show a lot about various science things, but we haven't had you talk about
have.
what it is you actually do for research, for
No,
study. What is that?
No, I have alluded to in the past that I get rats drunk for a living,
Yeah.
and that's what I do. I do research in addiction neuroscience, and yeah, that's what I do. I my curiosity kills a few rats.
Oh, no. Sorry,
I say
Peter.
uncomfortably. Look around.
It's
and,
okay.
and
You're a
shiver.
vegetarian. It balances out on the karmic scale.
Well, see, no, legitimately, I say this a lot, right? I say, I don't eat animals, I just experiment on them, so I'm, like, on a moral level playing field with, you know, the vast majority of the population, right? Like, that's... Yeah, anyway. No, okay, I'm not actually shitting on animal research here, because, like, honestly, this stuff, and as you'll probably hear me get really worked up as this podcast goes on, I am very passionate about this area of research, and I think it's very important, and the sort of stuff that we do, it's like, I mean, you can't do this on humans, right? Like, you can't just get a random human off the street and pump drugs into their brain and see what happens.
I mean, you'd certainly get a lot of people who would definitely put their hands up for that, right? You'd have a lot of people who 100% would sell themselves just for the case of drugs, which I feel like is the psychology of what you're researching, right?
But also, like, part of my research involves imaging brain sections, which involves slicing up the brain, which involves removing the brain, which involves a slightly little tiny bit of death. So yeah, no, the sort of stuff I do, like, yeah, it does kind of make me a little uncomfortable sometimes that we're doing this with animals, but I think, you know, my sort of drive to understand these things and the importance, I think, of understanding these things, like, and these things, I say very sweepingly, but these things being the biological, you know, molecular level underpinnings of addiction, which is a disease. It's a real illness, right? And we kind of need to understand these things so that we can develop effective treatments and help people.
Yeah.
And I think this is a really important thing. And beyond just developing treatments and helping people, I think understanding the neuroscience, understanding, you know, the receptors that go out of whack, the, you know, all this dysregulate, you know, the fact that this is a physiological, biologically underpinned process. Some stuff happens in the brain that causes people to relapse, for example.
It's not just people being, you know, quote unquote weak-willed or anything like that.
Well, this is the thing, and, you know, it took so long for addiction to even be recognized as an illness, right? For so long, people just thought it was like poor moral choices, and the relapse was just like weak will. But this sort of research that I do, like the neuroscience of addiction, kind of helps reinforce that this is a biological thing, and that, you know, it is an illness. It's a biologic, like, it's neuroscience. It's just as much my research and my lab at, you know, the Florey, like, I don't know if I've said this in previous episodes, but I will shout out, like, the Florey Institute of Neuroscience and Mental Health, and that's where, like, I do my research. I'm part of the addiction laboratory there, and, you know, our lab is just as valid as, you know, the dementia lab, you know, the the lab that looks at multiple sclerosis, the lab that, you know, these are all neuro
degenerative illnesses, or not
neuroscience.
degenerative, sorry, that was
No,
last week.
neurodegenerative would be, yeah. No, but these
By the way,
all...
you know, if you haven't listened to last week's episode featuring Luke Wiley, where we look at phenotyping and neurodegenerative illnesses. Thanks again, Luke, for coming on the show.
And then the episode before that with Elisa, where we talk about synapses, I'm also going to talk about synapses a little wee bit, but yeah, that's a good kind of basis to what I'm going to go into this episode if you haven't listened to that. But yeah, so, you know, that's my kind of like philosophical, moral, ethical rant out of the way.
Yeah. So
in terms of the research that I actually do.
So tell us
now
a
I'm
bit
talk
about
the cool stuff.
What is it you do? What is it you found out? What do you want to share with the world?
Okay, so a lot of what I'm going to talk about today is not at all what I personally have found out. Like, you know, that's the thing with like individual neuroscience, not just neuroscience, what am I saying? Individual like research projects and you know, they're very, very niche. Like what I look at is a very, very small, selective, tiny little thing. And, you know,
That's what she said. I'm sorry, keep going. It's important to you. I'm sorry.
You ruin everything for me. Why?
Oh, wow.
Anyway.
Wow,
that was sweeping and harsh, and I'm sorry. No, okay. The point, yeah, okay. No, this I'm sorry.
It's fine.
I'm sorry,
it's
world.
Fine. I know.
The point is what I look at is very, very small and specific, and kind of like if I spoke about that would be not as interesting as talking about like we kind of we tackle broader topics in this podcast, right?
What field of research do you contribute to? I guess could be another phrasing of the question.
So addiction. Let's look at addiction. That's where I want to go with this. That's where I want to start, right? So addiction. Now people, you know, if you're going to go and be politically correct, we don't like to call people addicts anymore. We call them suffering from substance use disorders, or you know, specifically I look at alcohol, right? Which is it's no longer called alcoholism or whatever.
What's the official term?
It's alcohol use disorder.
Right.
Is the DSM title for the disorder, the illness. So let's just look at the DSM criteria for alcohol use disorder.
Sorry, what's the DSM?
So the DSM.
What is the DSM?
Right. So the DSM, I forget that. Yeah, no, this is why you're here, to
Us
make
normies.
me make sense. Okay, so DSM stands for Diagnostic Statistical Manual, and it's like pretty much the Bible of psychiatrists and psychologists that want to, you know, give people's diagnoses. Well, give them diagnoses, right? Give them labels, and it's, you know, it clusters symptoms and gives them labels, and it's, you know, how we diagnose depression and anxiety disorders, etc. But there's a group in the DSM of addiction-like disorders, right? So we've got substance use disorder, but specifically a type of that is alcohol use disorder.
Right.
And pretty much you have to meet, like, I think it's 2 out of, I think there's 11 criteria in total. But essentially these criteria can be grouped into like 4 main key kind of like clusters, right? So the first one of that is impaired control of use of drugs, so of alcohol, right? So you don't have control over your use of this substance. You kind of, you know, it's impulsive and it's compulsive. Like you're drawn to use it. The second one is social impairment. So how much your use of this substance fucks up your relationships, essentially.
Right.
And how much, yeah. The third one is around like the risk of use and risky use. So not with alcohol, for example, but for, you know, say a drug that you inject, how likely are you to like grab a rusty old needle and shove that in? Like, you know, how much are you willing to sort of do dangerous things and things that you know are a risk in order to acquire
this
the
risk
drug.
to reward ratio is kind of skewed in a way that's probably going to do you a lot of harm.
Oh yeah. And there's reasons for that I'll go into a little bit, but yeah. And then the fourth one is around the pharmacological properties of the drug. But yeah. Like the majority of these diagnostic criteria are around behavior, right? Which is a kind of it's a little bit different to how you might approach other illnesses. And I think this is a lot of the reason why people don't see this as a valid illness so much, is because the behavior is the symptom and the diagnosis, but then also the way we treat it is sometimes a little, anyway, That's not the point. But that's where a lot of my research is in behavior, right? And looking at behavior and seeing how we can potentially change these behavioral symptoms. And therefore, if we can figure out how we change these behavioral symptoms, then we can, well, first of all, we know what's causing the behavior if we've figured out how to change it. But then also we can maybe create medications that can change this behavior and help people. So, okay. Let's just break it down. Let's just like dive into the nitty-gritty of the brain for a hot second and just look at like the concept of reward. In the brain, there's a lot of different pathways, there's a lot of different areas, and pathways are just the things that join all these different areas, and different pathways light up based on different things. That's pretty
These
common sense.
pathways are made up of synapses, right?
Yes, different neurons connecting to each other via synapses.
Yeah.
Well done. You've
Learning.
learned something in the last
2 weeks.
Love that.
Yeah.
Love that for you. Yeah, and I'll get to that a little bit more in a second, but just generally speaking, there's a pathway, well there's a few pathways, but there's kind of a one pathway in the brain that's generally vaguely known as the reward pathway, I say in quotation marks.
Right.
Or the mesocorticolimbic pathway.
I'm gonna call it the reward pathway.
Technical with names, but we're just gonna call it the reward pathway. Cool. And a very key feature of this reward pathway, which I think a lot of people know or have heard, is dopamine, right? The neurotransmitter dopamine and
I've
dopamine
definitely
release.
Heard of dopamine.
You've definitely heard of dopamine. Tell me what you know about dopamine. Let's do it this way.
I'm gonna ask you,
what do you know about dopamine?
Kind of I don't know. I guess you could call it I'll call it the quick fix chemical that the body makes, right? I think it's like one of the hormones or chemicals that gives you satisfaction or pleasure or happiness. So like you get a hit of dopamine if you I don't know, you drive a car really fast. I mean, that's also adrenaline, but then from the adrenaline, I think you also get a rush of dopamine, or, doing drugs or alcohol or sex, things like that give you that kind of instant gratification rather than kind of a more blissful happiness, which I think is serotonin does that. Dopamine's kind of like your sugar rush of happiness, right?
I love that you gave that answer because, like, watch me be Luke Skywalker right now and say, honey, every word of what you said is wrong.
What?
It's not. I can't remember the exact Star Wars quote, but I wish I could and just, like, shove it in that moment.
That was Last Jedi, wasn't it?
Yeah.
He's talking to Kylo?
Yeah. No, he says it to Rey, and I'm pretty sure he says it also to Kylo as, like, a callback. Anyway, not the point.
Okay.
The point is, so I love that you said that because that is a very common... I mean, okay, maybe not every word of what you said was wrong. Some of what you said was vaguely correct, but some of what you said was a very common sort of misconception. Right? So first of all, you kind of said that like dopamine was, that quick fix kind of gives you pleasure. So the bit that was correct is that you're very right when you do a line of Coke or, drink some alcohol or have sex or, eat chocolate. If you're not me, I don't like chocolate. Weird fun fact for everyone. So I don't find chocolate pleasurable, but maybe someone who does.
Outstanding.
Yeah, no, I don't know. For some, or like, you give someone you quite like a hug. I don't know. All of these things, you're right, that very much triggers a dopamine release within this reward circuitry. Now, the bit that was incorrect and that a lot of people kind of get wrong is that dopamine is not what's making you feel pleasure. It's definitely correlated with pleasure, but it's not the cause of pleasure. And we know this from a few different experiments, both in humans and in animals, where we've, given people a drug that blocks dopamine, a dopamine antagonist, and they were still able to kind of feel the pleasurable effects of something. Or in rats, we pretty much essentially just destroyed the dopamine neurons within the brain, so they don't work, and they still showed signs of being happy when they were eating their little sugar thing, right? So we know it's not necessary for pleasure, but like it's correlated every time.
Right, yeah.
But there was one experiment that kind of like really hints at what it might be doing, and that shows that in, I think it was cocaine in rats, but it was definitely in rats and some addictive substance. They found that the dopamine release happened just before the rats gave themselves a hit of the drug.
Oh.
So it's more... So the hypothesis that comes from this is that, you know, the dopamine makes you shiver with anticipation.
Yeah, love that.
No, it's probably more likely activation of perhaps our endogenous opioid system. So, like, for those of you that don't know, our brain and our body, like, we make our own opioids. So things like endorphins that you've probably heard of before, or enkephalin, or like, these are opioids, and they bind to opioid receptors similar to heroin or whatever, and they work to, like, mask pain and sort of make us feel good. And we think that maybe activation of that system.
The episode, it was one of the listener
I
questions
definitely
where someone was like the myth about someone lifting up a car in like a time of crisis, and how the body released opioids to kind of manage the pain with that, but we kind of debunk
to mask the pain.
Yeah, that's only a fraction of.
Okay, well, this is kind of a good segue into like how drugs of abuse actually kind of work in the brain. So the thing is, I'll come back to dope. I'll come back to dopamine in a second.
Sure.
But like essentially, you can think this is kind of one of the hypotheses, and there's kind of a little bit of debate around this still, but you can think of it as like you can separate addiction into, or not addiction, sorry, you can separate like, you know, the experience of getting something and it giving you pleasure into two separate things. There's the wanting and there's the liking, right? So there's the bit that makes you want the thing and anticipate the reward and crave the thing. And that's dopamine, right? Dopamine is the motivation. Dopamine is what drives you to want the thing. But then the actual, like, feeling good as a result of the thing, we think that's possibly opioids. There could be a bit of serotonin in that. There's, you know, but that's not the dopamine is the point.
So the dopamine is what gives you the craving for
the craving, the motivation,
desire, whether it's sex or drugs or rock and roll.
Exactly. And that's the thing. And so this reward system in our brain, right, is very, like, it's naturally stimulated by things that were, you know, evolutionarily advantageous, such as like sex, right? Procreate. Take my genes and make babies with them. That's a good thing. We want that. Eating food. Fantastic. Need that to stay alive.
Yeah.
That's a helpful thing. You know, these kind of rewarding things. And the cool thing, and I'll come back to this, but the cool thing is that dopamine's not just kind of making you want that, but this whole process and in this reward circuitry, it doesn't just take note of like, oh, that thing was good. It goes, okay, that thing was good. Let me just take note of where I am, what I'm doing, what's around me, how I can maybe remember this shit so that I can hit this up again and get this good old feeling again. And the thing about addiction is that, like, so natural rewards do that in like a healthy kind of way, but addiction, like drugs of abuse, hijack this system and just send it hell out of whack. And so that's all you can think about is like, shit, how do I get that good thing again? But I'm just going to come back to what you were saying about, like, so how I was saying, like, different drugs work in different ways and how we were talking about opioids.
Yeah.
So, like, drugs of abuse, right, you can kind of group them into two main sort of ways they fuck up the brain. Way number one, they mimic something that our body already makes. So like I was saying, we make opioids. We have enkephalin, we have endorphins, we have these endogenous opioids. We also have endocannabinoids, right? So we have cannabis-like molecules that our body makes. So, you know, things like heroin, they mimic these already existing, and, you know, tobacco binds to your nicotinic receptors, which is for acetylcholine, which is another neurotransmitter that exists in the body. Right. So these drugs kind of mimic existing things and bind to their receptors, but do it better. Right. And so the brain goes, oh, this is a good thing that I have, but like, oh, it's real fucking good. And then there's other drugs that they don't do that, but they stuff up how much of your body's natural neurotransmitter gets released or gets, sucked back up by the neuron in the synapse. So this is where, you know, synapses, brief, you know, overview for anyone who didn't listen to our episode with Elisa. Listen to our episode with Elisa. But synapses are the gaps between neurons where, you know, we know within a neuron it's electrical energy, but between neurons it's chemical energy.
Yeah.
And this is where dopamine comes in, right? So in this particular synapse in the nucleus accumbens, but, you know, in this particular synapse in this part of the brain, dopamine gets released from one neuron to the next neuron. And that, you know, drives our craving, drives our whatever. drugs like amphetamine and cocaine, they don't bind, like, they don't, act in place of dopamine, for example, but they make the amount of our natural dopamine that gets released into the synapse change. So drugs like amphetamine and cocaine, what they do is they make more dopamine go into the synapse, whether that be more being released into the synapse or less of it being sucked back up by the, the presynaptic neuron. The point is, what they do is they just abuse the body's natural dopamine and go, vroom, all of that into the synapse at once. Whereas these other drugs and things like alcohol act in a less direct way, and they bind to these other receptors which stuff up other signaling within the body, but it all eventually comes back to dopamine. And all of these drugs of abuse just like vomit out large amounts of dopamine in this like rewarding pathway. So what actually happens in addiction is the body goes, holy shit, that's a fuck ton of dopamine, cannot deal, don't need that much. I'm going to get rid of some of these receptors because we don't need it. So the same big rush of dopamine causes less of a response. And the more you use, the less of a response it gets. And this is kind of the same as like tolerance to drugs, right? You need more to get the same effect. And that's because we have like less receptors or less things breaking the dopamine down. Like the body compensates. So if you're drinking every day large amounts, your body's going to compensate for that. And it's not just in dopamine, especially with alcohol. Alcohol is, as we know, a depressant, and it binds to, one of the main effects it has in the body is activating what's called, your GABA system, which is your main sort of inhibitory neurotransmitter in the body, and that's kind of why we slow down and get disinhibited, etc. So when we're getting lots of that, the body kind of overcompensates and it shoots up our excitatory neurotransmitters, which is like our glutamate, for example. And so when you're used to drinking every day, your body kind of compensates, bracing itself for, this effect of alcohol to slow you down. And then when you stop getting that alcohol, your body's almost overfiring, right, to compensate. So you're underfiring in your dopamine system, you're overfiring your glutamate. That's why people in withdrawal from alcohol have shaky hands, is because their glutamate system is overfiring to compensate for the GABA, but then they're hella depressed because their dopamine system is underfiring and they don't experience, like, things like eating chocolate no longer gives them reward because they're used to a drug, man. This so natural like reward's got nothing on that.
Drugs and everything in the brain just like not short circuits, but overpowers and really fucks with
it hijacks your entire reward system and sends everything out of whack. And so your experience of pleasure, and the more you use, and the experience of pleasure is all just messed up. And that's kind of how tolerance works, and dependence, and why people get addicted.
Is it reversible though?
Yeah.
Or is it like hearing, where once it's gone, it's gone? Like you lose a bunch of receptors, you overload these things. Is that something that can be worked and re-established?
Of course it can. Yeah.
Okay.
Yeah. So the whole, it's a myth that the brain loses plasticity after you turn 20 or whatever. Like, it is 100% possible to reverse these changes, and that's what treatments aim to do, and that kind of leads well onto what I was going to talk about next, and how it's sort of one of the main treatment aims for once again we're just going to talk about alcohol addicts, but I'm pretty sure most people with most substance use disorders is abstinence, right? Is to just stop using that thing. And that's because
sounds like a game show.
Then when you stop using that thing. Yeah. No, but seriously, stop using that thing. If you're addicted to it, stop. Because if it's the substance that's kind of fed this, spiral that's led to the addiction, right? You need to kind of take the substance away to reverse it. But the complicated thing is that it's not that simple as, most people who've, ever witnessed anyone with an addiction can probably very easily attest to, right?
Yeah.
Is it's not just that simple of just being like, I should stop. Like literally the biggest kind of hurdle that addiction treatments try to overcome is relapse rates. Relapse rates in addiction disorders is huge. And so for those of you who don't know, relapse is just defined as the return to substance use after a period of abstinence, so after a period of not using. But that's such a shallow empty definition, right? So lots of things can trigger relapse, right? Lots of things, such as like stress, for example, whether that be like emotional stress or physiological stress, like if you're
like,
sick or if you have,
man, I need a drink
you get
after
divorced
that.
or you lose your job or whatever. Like, well, yeah, I have a lot of thoughts about the problematic, society very much normalizing the need to have a beer to wind down after a hard day or whatever. There's a lot of issues with that.
That's a whole
I'm
other
not going to
kettle
go
of
into
fish.
that. Yeah, but for people, I'm just talking at the moment for people who have alcohol use disorder or substance use disorder, who are diagnosed with this thing. They have stopped using their drug of choice, drug of abuse. They're abstinent, and then something causes them to start using again, and it is a relapse where they start using and they start, it will lead to abusing again, because one of the things that can trigger that relapse is like re-exposure to the drug, and it will spiral a lot quicker than someone who has never been addicted to that thing before. But stress isn't the only thing that can cause it, right? So you've got or use of the drug again. You've also got, and this is actually what my research looks at, which is context induced relapse.
Right.
Which is like, say, for example, you've got a mate, he's your best mate. This is, let's say, pre-COVID times. You always would go to that mate's place and get drunk. And that's the only thing you would do at that mate's place, right? Is you'd go and you'd smash beers, maybe play some PlayStation, I don't know, but you'd get drunk. You can actually learn, like, what your brain does. Your brain is very clever, / also not clever when it comes to things like drugs that you don't necessarily want to be building these associations. But what the brain does is it goes, okay, getting drunk with my mate was hell fun. That's rewarding. That's cool. That's where we get that dopamine reward system firing.
Yeah.
But then the brain goes, okay, cool. How can I do this again? Let me take note. Okay, so I'm at my mate's place. Cool. And it takes in the context, the environment, the collection of these environmental cues, these environmental stimuli, that make up where you are. And it goes, right, I'm going to link this with drinking and the rewarding feelings that come with drinking. So then say, you're a couple months sober, you haven't seen your mate in a while because he's your drinking buddy, but you think, you're solid enough in your sobriety that you can go over to your mate's house again, but you don't plan on drinking.
Yeah.
You go over there, just being in his house could trigger a relapse because your brain goes, oh shit, I recognize this environment. I can get my drugs here.
Right.
I can get my rush here.
This is the
I can get my high here.
This is why I come
can
here.
get my happy here.
Yeah.
If your mate goes, hey, you want a beer? If he'd said that and you were like in a park where you'd never been before, you might have been strong enough in your sobriety to say, no, I don't drink. But if you're in that place that your brain has linked to drinking, like, you are far more likely to just say yes, or to take the drink without even realizing you've said yes. Like, that's the thing.
Second nature.
There's biological processes that are just kind of driving this motivation without necessarily you having that conscious control of it or awareness of it. And that's what's really dangerous in, the way we treat alcohol use disorders or substance use disorders, and we send people away to a rehab and they live there and they don't have access to their alcohol or their drugs there, but then we send them back out
away. They learn how to be sober and live life as sober, but it's all in this environment that's completely different from what they're used to. So as soon as they go back home, all of the old environmental stimuli just kicks in and they're like, okay, it's drinking time, because I'm not where I didn't do the drinking, I'm where I do the drinking. do But
yeah, and there's a lot of research to suggest that that's why rehab centers have such high relapse rates, because they do. Like, it's well known that these places have really high relapse rates and people are in and out of them, and and then that's the thing. Like, they're very effective at getting people sober in that scenario, but then they take them back out into the real world and they haven't accounted for the fact that their brain has done this thing where it's linked. And not just places, like different cues, like, and you're driving down the street and you see massive billboards slashed with advertisements for alcohol or whatever, things like that can, trigger relapse. Like, they've done these studies where they've gotten, cocaine addicts, for example, and they've, shown them just like pictures of the tools that they used to use cocaine and the parts of their brain looking for a reward, looking for, lit up in fMRI scanners. Like, these are enough to trigger things in addicts. And this is what my research is in, and because that's what's the really cool thing, is that we can model this in animals, in rats. It's called ABA renewal, and it's a way that we can model context-induced relapse in animals. And it's really flippin'. I mean, it's not cool. It's kind of sad for the animal.
The research is cool,
but it,
and it's sad for the animal, but the help and improvement that this is going to have for people and trying to overcome addiction is super
because we can look at
important.
different things. Like, if we have this robust model of relapse, then we can test different things and see what stops the relapse. And when we do that, then we can then backtrack and go, okay, this drug stops the relapse, then that means this thing that the drug blocked is probably what's causing the relapse.
So probably to wrap us up, as we're probably going a little bit over time here, I just have one more question for you. What advice would you give as a scientist studying this sort of stuff to potentially, people with addiction in their lives or addicts in this? Just because, I'm hearing stuff like, even stuff that could be good for addicts like rehab and that sort of stuff do still have a high rate of relapse. I'm assuming that doesn't mean to completely discount the idea of rehab altogether. Crux of the question being, I don't know, some of the stuff I was hearing, I was thinking kind of like some of these conventional treatments that people know for addiction are proving to be not necessarily not effective, but not as effective as people might think. So,
that's why I spend so much time. Actually, this is probably, we'll keep going with this. I spend so much time trying to argue why my research is important, right? Because this is a very big thing in every thing that you write about your research or every talk that you give, is you need to argue why your research is important. And a very big part of why my research is important is that the treatments that we currently have are not effective enough. Like, there are medications to help with alcohol use disorder. There are a few that are FDA approved, but there's flaws with all of them in terms of compliance rates, in terms of side effects. Like I said, with rehabs, they're not necessary. They don't take into account this context-induced relapse phenomenon. And there aren't any medications that do. And so that's where, my research comes in, and we're kind of looking at this compound or a couple of compounds that may be able to, turn into future medications that target this underlying biological drive to relapse in certain contexts. But I'm so used to arguing from that angle that I kind of forget that, for people hearing this, it's just like a tale of woe and doom. And like, that's really not what I want this to be at all. Because like, the fact of the matter is, we argue that yes, these things are not as effective as they could be. But the fact is, there are also heaps of options out there. So, yes, rehabs are not necessarily effective in terms of taking into mind this context-induced relapse. But if they can get you sober enough that some of your cognitive capacities return, and then you can go into therapies like things like CBT, so cognitive behavioral therapy, or DBT, dialectical behavioral therapy, these psychological like therapies that help you kind of work through, first of all, why am I using this drug? Because for a lot of people, there's underlying psychological reasons that drive them to use in the first place. And if you can remove those, then, and also, so if you can work through these things, and then if you've got, for example, like opioid addictions, there are medications, things like naltrexone, they're kind of replacement therapies that sort of, they don't treat the underlying biology, which is why the research that we do is still so important, because ideally eventually there will be drugs that do that. But what they do is they kind of take the edge off the withdrawal symptoms, and they take the edge off what it feels like to come off these things, or they remove the rewarding feeling that you get when you take these drugs. Or, for example, disulfiram is a medication for alcohol use disorder, and it does this thing where it doesn't work in the brain, it works in the liver, and it actually stops your body from like breaking down or metabolizing alcohol properly, and so you get really sick. And so when you drink, you get very ill, and it sort of therefore acts as a deterrent for drinking. And like, stuff like this exists, and they're not perfect. They're far from perfect. But they're better than nothing, and they're better than sitting alone in your room with your bottle of whiskey or your bong or your whatever you're struggling with and not talking to anyone. Like, go seek the help.
If nothing else, like even if these things like rehabs aren't necessarily long-term solutions, they sure are a good jump start out of that hole
for sure. And
to kind of help you on that climb.
And if you go to a GP or you go to a doctor and you talk about the fact that you're struggling with these things, there are medications out there that can help, take some of this off. And then you can go and you can get these psychological therapies that can help you work through it. And, 12-step programs, there's a lot of debate about whether these sorts of things like Alcoholics Anonymous, for example, whether these are actually effective. But like, if nothing else, they don't hurt. They just offer this group support. You can go, you can talk about your feelings, you can talk about what you're going through with a bunch of people that have been through that and who get that. And I think just some of these, like, especially with substance use disorders though, and like things that are like shrouded in as much stigma as these diseases are.
No, that's good to know that those things.
Yeah. No, it's I think, it's important to understand that like there's still a lot that we don't understand and that we should
which is what
be
you're
really aiming to learn these
like,
things,
that's
right?
what you and your research is going towards, to try and work out better and more effective.
It's a better future, and that's what we want. But that's not to say that anyone who is currently suffering from these things that you're stuffed. You're not. Yeah. You're not stuffed. I'm really glad you asked me that question because that is a very good point, and I don't want.
It's a bit of a heavier note to end it on, but I think it's an important note to end it on.
No, well, it's a heavy topic. It's really hard, especially because this is in the middle of a pandemic at the moment, right? And people are maybe drinking more than they normally would, or using substances more than they normally would because they're home and they don't have to drive anywhere, or they don't have to whatever. Like it's. I don't want anyone to feel like, they're at a dead end.
Yeah.
Go to your doctor. There is help. And hopefully, and like, just rest assured that like there is research out there and scientists that know that this is a biological thing. Yeah.
All right. I think that's where we should wrap it up for today's episode. Thank you so much for speaking about your research, Kate, and really taking a deep dive into, a science that you are really passionate about.
Yeah, I could talk for hours and hours, and I didn't even touch the surface of what I look at.
I'm sure we'll have future episodes where we can have a longer time to really deep dive into this stuff.
Yeah. Well, thank you also to Pint of Science for, calling upon our podcast to help bring the science to the people in the absence of pubs being open. And, if you want to check out any more Pint of Science stuff, you can look them up on Twitter at PintAU, and also check out the hashtag PintAU online. And, as usual, you can find, you know what I'm going to do? I'm going to plug my own personal Twitter for once.
Go on.
Because you know what? I talked about my own shit today. And if you like addiction, no, that's wrong. If you're interested in more about what I have to say personally, rather than just, the podcast, you can find me at Huckstep Kate, on Twitter. Or you can find us, as always, at Curiosity Rat on Twitter, Insta, or Curiosity Killed the Rat on Facebook. And you can email us at, what is our email address, Matt?
curiosityrat@gmail.com. Going forward, we'll be going back to our regularly scheduled program starting next fortnight. Usual length episodes, always with the listener question at the end. So,
listener questions, lay them on us. We are ready, we are open, we are keen.
Catch you next time.
Peace out, homie G's.
Curiosity. Kill the rat. Curiosity. Kill the rat.